to another episode of Coder Conversations. Today we have Frontend Master Kyle Simpson. Welcome to the show.
Thanks so much. It's awesome to be here.
Oh man, we're definitely glad to have you. Just to get started, man, can you tell us a little bit about your background? How did you get into coding? What made you pick JavaScript?
Yeah, for sure. So actually, I got started a long time ago, 1990/1991. I was a young kid, and I was over at a friend's house whose dad was a professional programmer, and my friend and I were just messing around playing video games and stuff like that. And we went into the den where his dad was working. And as I recall, I think he was working on an old version of Borland C++, or Borland C or something like that. But certainly DOS days. This is pre Windows. We just saw him messing around programming, and we wondered, curiosity, what is that? So we started peppering him with stupid young kid questions. And at one point, he was explaining stuff. I don't even remember what he said, but at one point he said, "Hold on just a moment," and he clicked for the way I remember it, less than a minute. It was quickly, and the screen went blue, like a blank blue, with a gray box in the middle, and it had my name in the middle of the box. And I was hooked. I was completely fascinated that with just a few strokes of the keyboard, he was able to make it do that and make my name show up there. So, like any young kid, I thought, oh, I'm going to be a game developer. I'm going to learn how to program so I can make games. So my friend and I both kind of, as young kids into our preteen and teen years, we started learning how to program so that we could write games. And so the first programming language I ever learned was called QBasic, which was a Microsoft variant of BASIC. And that was in 1991. So that's how I got into programming. As a kid and a teenager and all the way up through high school, did it kind of on and off for fun and a hobby and things like that, and really enjoyed it. I eventually migrated over to C++ and Turbo Pascal in the mid 90s and started building applications for like actual pay. I got paid to build an inventory management application for a bike shop, which is kind of a random thing, but got paid to build that. And, just kept going. By the late 90s, I was enamored with the web. I was in college. And so I started looking into web stack languages. I learned an early precursor to PHP and then moved into PHP. Started learning JavaScript in like 1999. Probably by 2003, I had decided that JavaScript was the language that I wanted to specialize in. And I made this early bet that there were going to need to be JavaScript specialists long before anybody imagined that that would be the case. And that turned out to be a pretty good bet. So all the way through the early to mid 2000s, I was kind of pretty exclusively focused on JavaScript. And in 2011, late 2011 and 2012, it's kind of the big shift in my career. I moved from being a developer for hire, working in the industry, to being community focused, went independent, started teaching and writing. And most people out there have heard of my book series, the You Don't Know JS books. If you're in the JavaScript space, we kind of joke in my family, we call this it's kind of like being what we call weatherman famous. In your town, your local weatherman is like super famous, and anybody that sees them at a store, you're like that. And then out of that town, nobody knows who the hell they are. So it's sort of like that, like being a little bit famous in a very small pool, and then nobody else knows anything about me outside of that. But yeah, I did a bunch of teaching and writing and speaking and all that stuff up until the pandemic. And then it sort of ended that business model. And so I, over the last couple of years, have been trying to find my way back into the workplace. So that's kind of how my story of being a developer.
Okay, yeah, I know. Like back in the day, JavaScript was kind of looked at as a, script kiddie language. It wasn't looked at,
Mm.
favorably amongst elite programmers. What made you kind of like stick with JavaScript even in light of that?
Yeah. Well, actually, I think I'm in that respect fortunate that my personality type almost is by default attracted to the types of things that most other people are inclined to discount. Um, so, for example, in college, I studied CS, computer science, and one of my favorite courses was compiler theory. And I still kind of geek out on compiler theory. I still enjoy writing that kind of stuff, and tools I build often have some flavor of that. But this compiler theory course, the job was, or the task was to build a compiler throughout the whole semester. Could use whatever language you wanted to build the compiler in, and then she gave us the specification for the language that we needed to compile, which was like a subset of C. But everybody else in the class picked the traditional languages like Java or C++ or whatever to implement their compiler in. I happened to be working at that time for a PHP shop, and they had a Smarty template engine. I don't know if anybody even remembers that, but we were using the Smarty template engine, and it had some stuff that it did that was kind of wonky and we didn't like and we wanted to change. But I didn't know how to like fork and edit that kind of code. So I went to the professor and asked if it would be all right for me to use PHP to implement my semester compiler project. And she laughed at me and she was like, "That's crazy. But yes, I'll let you do it because I didn't say otherwise. So yes, I have to allow you to do it." But she kind of chastised me that I was probably going to regret the decision. So you fast forward through that semester, and while all the other students in the class were messing around with like allocating memory to do string management, I was already well advanced into the implementation of the features because PHP just did all that stuff for me and I didn't have to worry about it. Um, and so by the end of the class, she called me into her office and she said, yours was the only project to complete all the objectives and the bonus objectives. And it was at least twice as fast as the next fastest submission by any student. And so she had to admit that maybe it wasn't such a crazy idea to use PHP. So that's sort of always been my bent, is that I gravitate towards rethinking or approaching things that are discounted. And so JavaScript did not get a lot of respect. Even today, it doesn't get a lot of respect, but it did not get a lot of respect in the early 2000s. And I think that's one of the reasons why I gravitated toward it, because I felt like there were untapped potential that if somebody would spend the time to pay attention to, we could dig in, and uncover that. So that's kind of what initially attracted me to it. What kept me at it was that I picked it up pretty quickly, and it's kind of addicting. I think most engineers feel this way, but it's kind of addicting when you feel strongly enough in a language that you can't really imagine anything that you would like to program that you couldn't program. That power, that freedom is addicting. And because I had that mastery over JavaScript, I already had by that point almost a dozen other programming languages that I had worked in to some extent, including Perl and Python and some other stuff like Java, things like that. None of those languages enamored me with that sort of flexibility the way JavaScript did. And so I think that's the staying power that kept me going.
So I know there's like several revisions of JavaScript, ES3, ES5, ES6. When did you feel like it really started becoming good?
I think ES6 clearly was a huge inflection point for the language, but I think maybe even more importantly than ES6 was the ES5.1 revision. Often overlooked, the major addition in that sort of minor incremental update when ECMA officially adopted the ES5 standard and they called it 5.1. The major addition was strict mode. And I actually think that was probably the first time that anybody outside of JavaScript could imagine respecting JavaScript as a language. Certainly, strict mode didn't fix a lot of the problems, and there's still plenty for people to bellyache and complain about. But I think it represented an inflection point where JavaScript became self-aware of the need to address some of its issues. And I think that that was probably a big point for me, certainly, once I understood the importance of strict mode. Um, that was an inflection point where I took the language much more seriously as well. And I think a lot of people did. Around that same time, I think the other big thing that happened for the language was Doug Crockford writing JavaScript, the good parts. And I've had plenty of public interactions, many not so great, with Doug Crockford over the years. Haven't talked to him in I don't even know how long, but he and I have sparred from time to time. But he deserves a ton of respect. If for nothing else, if he did nothing else, and he did a lot for our industry and for the platform, if he did nothing else, he deserves a ton of respect, because basically anybody who calls themselves a JavaScript engineer right now, if you're employed being a JavaScript engineer, in some way, shape, or form, you owe it to Doug Crockford, because the direction of the industry was moving away from respecting JavaScript as a key part of the web platform. And we saw a lot of fragmentation of the web platform and a lot of vendors that thought they had the better idea for how the web platform should run. What should that language underpinning be? Microsoft had like 14 different languages that they tried to stuff in the browser, from VBScript to Silverlight and all the .NET stuff. But other people, Google's tried to invent multiple languages. There's a lot of would-be successors to JavaScript. And I think one of them, at least one of them, would have won if it was not for Doug Crockford writing that book. And so it turned the whole industry around, and it convinced an entire generation of developers to take JavaScript more seriously than they had ever considered to do before. So whatever you may think of the guy, and I certainly have my own opinions of him, I thank him for the fact that today I still have a job in JavaScript.
So yeah, I know JavaScript's kind of been taking a bent towards like functional programming. Do you like that direction?
I almost would dispute the premise of the question, because from my perspective, JavaScript has not done hardly anything to actually serve the needs of functional programmers. I never considered myself to be part of the functional programming in crowd, because I could never understand, even with a CS degree and a math minor background, the heavy theory and mathematical notation and terminology that underpins most of functional programming, the traditional way of explaining and teaching it. I could never understand it. And I spent a decade or more trying to, and couldn't understand it. And so I kind of went on my own journey, similar to my journey to learn JavaScript. I went on my own journey over the last 7 years now, to learn and understand functional programming in a very pragmatic way and in a JavaScript centric way, meaning my only interest in functional programming is how it can be adapted to JavaScript. I have not chosen to learn Haskell, or I know a tiny bit of Haskell, but I haven't chosen to learn Haskell or Scala or any of the other functional languages. I've chosen to learn functional programming in the context of how it can be expressed in JavaScript. And that's been an unconventional path, but similar to how I did with JavaScript, I wrote a book to detail my journey, my learning journey. I made courses about it. And as it stands today, I would say that I am far more a functional programmer than any other paradigm. But to do functional programming well in JavaScript means that you have to adopt a more pragmatic mindset than functional programmers typically adopt, because the language and the paradigm is just very different. So I look from that perspective, or from those lenses. I look at JavaScript with a lot of lament that there's a lot of missed opportunities that the language and the language design has fumbled over. And we are currently fumbling over. I'm involved in several discussion threads about proposals for features to add to the language, and I feel frustrated regularly that it doesn't seem like functional programming really gets any respect from the language designers. Um, and that's not entirely TC39's fault, because generally the functional programming community has not been super welcoming to other paradigm and language communities. So I can certainly understand why there's some animus or some kind of standoffishness. But there's a ton of stuff that I wish JavaScript would do to make functional programming more ergonomic and more performant, and they just we see them rolling out new features for class keyword by the day, and like literally every few weeks I see another proposal for something else to throw under the class keyword, but we don't get that same level of interest and respect for supporting functional programming.
Could you give an example of some, like you're at the top of your wish list of something you'd like to see them add in that respect?
Yeah, the top of my wish list right now is that I wish that they would have first-class syntactic support for declaring curried functions. The TC39 members are convinced that currying is academic bullshit and that real JavaScript programmers will never do it. But I'm convinced that real programmers would use it if it was ergonomic to do in the language, and it's not. And it's also not performant. A very close second to that would be proper tail calls, which are in the language spec and have been since 2015 ES6. But there's an open revolt where the browser vendors, most of the browser vendors, refuse to implement the thing that they voted and agreed on. Lack of proper tail calls is a travesty. It's an embarrassment that JavaScript does not support proper tail calls and more broadly tail call optimizations on top of proper tail calls. So those, maybe I actually should have said that first before the currying, but those two are neck and neck for my big complaints at the moment. I think the next one on the list would be the I'll probably upset some listeners when I say this, but the total horseshit that is the pipeline operator that they're trying to stuff into the language. It's just such a backwards way of trying to do something that looks like it's going to help functional programmers, and it completely ignores what functional programmers actually want and need. So
is that the question dot paren?
That is the optional call operator, which is maybe the worst thing that JavaScript has ever done. But no, the pipeline operator, it's like the pipe and then the arrow, the greater than symbol. It's an expression for taking the output of one expression and putting it into another expression so you can do function composition. But the way they designed it is just, it's abominable. I don't understand.
So yeah, what are some of the advantages of functional programming? If you had like a new JavaScript developer, why should he look down this road?
Yeah. So I would say that probably the biggest reason why I am an adherent or a believer in functional programming is that probably the most predominant thing that I observe, not only from my own code, but from the literally tens of thousands of engineers that I have taught, hands-on taught in both online and in physical workshops. The observation that I make is that it is a virtually universal experience that developers write a piece of code and they only partially understand how that code might supposed to be working. And then essentially they run a test and they kind of cross their fingers, hoping that the test will pass. And one of the maxims that I often am quoted as saying is that if you don't understand why a piece of code works, you have no hope of understanding why it breaks or how to fix it beyond pure guessing, right? Just throw some parentheses around it and rerun it, and hopefully that works, right? Like that is such a predominant problem in engineering, that we don't know why it is supposed to work. And when it works, we're pleasantly surprised. And that is not a good thing. That's way not good enough. That's such a low bar. So the reason why functional programming, one of the promises that I think of functional programming, is that it takes large swaths of your program and expresses them in a style that is underpinned by provable mathematics. And even if you don't understand the mathematics, which I don't, as I said earlier, even with a math minor degree, I don't really understand a lot of the deep math behind it. But even without understanding the math behind it, I can rely upon it in the same way that, if, mathematically, the proof for 1 + 1 is like 347 pages of mathematic notation. None of us listening here is likely qualified to understand and fully explain why 1 + 1 = 2. And yet we rely daily on 1 + 1 = 2. So you don't have to understand or be able to reprove, rederive the math to be able to take advantage of these things. So if you took a program that was, I'm just going to use an arbitrary number. If you took a 1,000-line program and said the status quo is that I only understand about a third of this program, and 2/3 of this program, 600 or so lines of this program, maybe work, maybe don't, but I don't know why they do or don't work. That, I think, is kind of a general status quo. And what functional programming promises is that you can actually flip that around and say that the majority of the program is built upon a mathematic principle that is guaranteed to do something. And there's no reason for you to spend any more mental cycles trying to figure it out. It's just guaranteed to do it. That way you could then focus all of your attention on like the 10 lines of code that actually matter. And the 990 lines of code that are underpinned with mathematic principle and already proven to do something are not something that you need to worry about. The punchline that I'm headed towards here is, and what attracted me to functional programming, was the promise that eventually I could understand what I was writing in my code so well and be able to trust what I was writing so well that before I ran the test suite, I knew exactly what the outcome was going to be, 100%. That's not to say that you don't write tests. Those are important. But how much more effective could we be as engineers if every time we wrote a line of code, we had 100% confidence that we knew what it was going to do and exactly under what conditions, and we didn't have to spend all of this guessing and uncertainty that takes up all of our mental power. So functional programming offers, among many benefits, that promise that we shift the majority of our program into this category where we do not have to spend our mental cycles reproving it over and over and over again. That's a done issue, and then we move on. We focus on the important stuff. So I'd say if that sounds interesting or beneficial to anyone that's listening, I think you should give functional programming another look.
I'm gonna go love me some monads.
Yes, monads are a more recent interest of mine. Over the last year or two, I've written a monad library for JavaScript because I became convinced that the big missing piece in JavaScript was not having a solid and ergonomic IO monad implementation for JavaScript to manage side effects. And built on top of that IO monad, I have been experimenting with essentially reinventing JavaScript frameworks on top of the IO monad, because it's just a far better primitive for these things than what we currently do.
So for anybody who doesn't know what a monad is, can you or Sean sort of shine some light on what a monad is?
Mm-hmm. I certainly can. Before I do, I'll sort of humorously quote. I'll quote Doug Crockford again. He's not even the original originator of this quote, but he made it famous. The curse of the monad, he called it, is that once you understand what a monad is, you stop being able to explain it to others. And that's a generalizable principle, that the more deeply we understand stuff, the harder it becomes to explain. We struggle as humans to have the empathy with our past selves. Can any of you remember what it was like before you understood a single line of JavaScript? That's hard to do. And it's hard then to empathize with that person who's learning their first line of JavaScript. The same is true of any programming concept, and it's especially true of complicated concepts like monad. Let me give you some metaphors for what a monad is. It is a way of representing a value in your program. And I'm going to use value in a very broad sense. Value is not simply the number 42 or a string. A value can literally be a chunk of actual executable code. So any value in your program, when you represent it as a monad, what you're doing is saying that I want for there to be a very predictable set of interactions between that thing, that representation, and anything else that is like that. So in a very coarse and not particularly precise way, it's kind of like an interface for those that are more familiar with traditional class-oriented coding. An interface says anything like this or anything that implements this interface has to be able to do the following things. Effectively, a monad is a representation of a value that respects a couple of very straightforward mathematical laws. And those mathematical laws, in particular, allow that representation of that value to interact with another value of that representation in a predictable and provable way. So what we do is, instead of working with numbers like 42 or strings like hello world or objects like the customer record, we lift those values into the monadic space. We represent them as monads. And then we mix and match and combine these monads using those mathematic principles. And it allows us to abstract a lot of the tasks that we normally are distracted by in our code. So for example, taking the concept of a value that is either present or empty, present or missing, that's a concept that plagues every program that's ever been written in every programming language. We always have to deal with, do I have my value or do I not have my value? And the way that we typically do that is we propagate that check to every place that the value needs to be used in the form of things like if statements. We have to do an if statement that says, if my value is present, do something. If my value is missing, assign it a default value, right? So what if you could take the concept of is present or is missing and wrap that up into the definition of a value, the monadic representation of that value, and that's called the maybe monad or the option monad, it's sometimes referred to. That's the concept of a value that's either present or not present. If we wrap that concept into the definition of the value, and then that thing is what we pass around and perform operations on, we don't ever have to write an if statement again to check whether the value is there. That's already being dealt with in the definition of the value. So there's all these different problems that we typically imperatively solve in our code. And there are a variety of very clever and interesting ways to represent that in the monadic style, which shifts the burden away from having to worry about that stuff and allows us to focus on the more interesting thing, like how do these two values combine and interact with each other? That's where my brain power ought to be spent. I ought not to have to spend all this time writing a bunch of bullshit if statements, if that makes any sense. So that's a very simplified kind of motivator. It's like the high school football coach trying to motivate his players. That's how I motivate you that you should look into monads, but that's not at all a sufficient explanation of them. I have written as part of that monad library I was talking about, which is called Monio, Monio is my library. There's a write-up on there where I went into quite a bit more detail to try to help people understand monads. So if I motivated you to give a shit about that topic, you might want to go and read that and see if any of that's useful.
I'll check it out. I'm curious.
Kevin, you're on mute once more.
Oh, sorry.
I like seeing his lips move, though. That was cool.
What are some of the more interesting projects that you've worked on that you can speak about? Have you worked on any games or?
More interesting projects. Well, let me talk about current stuff, because current stuff I'm much more interested in. I've got a long list. I could talk for hours about all the stuff I've done in the past. And like most people, I've got a longer list of stuff that I started and never finished than I do of stuff that I finished. But let me talk about some of the more recent things, other than that monad library that I talked about. One of the more recent things that has me that has a lot of my interest right now is application architecture that is centered on a privacy first mindset. And there's a variety of political and social reasons why this is in our current zeitgeist. It's a lot of complexity on both sides, and I don't even really care whether anybody listening to me feels one way or the other, or you're on one side or the other. I think we can all agree that right now, systems of government and systems of big tech and everywhere in between own way more of our data than they ought to. And again, you could be on an entirely opposite side of the political divide and still think that's absolutely true for different reasons, but still think that's absolutely true. So if you agree with me that we have a problem in society that entities own our data and we ought to own our data, then you can understand why that has my interest right now. What triggered this interest was here in the US, the Supreme Court ruling around abortion and abortion rights. And there was a fear that a lot of people had, and I think rightly so, that period tracking apps in particular might be used against people, weaponized in ways that are not okay. And right now, the status quo is that you have to trust that a privacy policy written by a for-profit company represents what they're actually going to do with your data. And that doesn't cut the mustard as far as I'm concerned. I am not a uterus having person, but I care about humans and I care about our rights. And because of those reasons, I think it's important that we try to address them. So I started building an app that would be a privacy focused period tracker. As I started building this, I realized a couple of things. First of all, I shouldn't build it myself. I should get a lot of other people in the community involved, and especially a lot of people that have uteruses involved. And so I created an open source project and attracted a bunch of other people to join. And so hopefully that they will drive that more even than me. But the other reason why this is interesting and why I bring it up is that as I started thinking about the reasons that drive having an application that runs local first, encrypted first, and never sends your data anywhere but your device, the same reasons why that's useful for someone who wants to track something like their period is also useful for someone who wants to track their mental health, or someone who wants to track their sexual health, or someone who wants to track any of a long list of things that matter to us as individuals, but it's our data. And why the hell is the status quo that everybody that builds a great app owns that data? That's totally wrong. It's totally backwards. We should be building every app that you can think of almost, other than a social media app. Almost every other app in existence actually should be flipped on its head and built with privacy first, and then maybe you can decide to share, rather than everything is shared and then you have to try to claw back your own data. So that's a big problem that I think exists globally, and my few lines of code are not going to solve that problem, but it's something that I think we need to attack. And so that's what I'm working on, and I'm going to spin off probably a half a dozen of these personal information trackers that are all built with the same concept of privacy first. and sharing last, right? Sharing, we shouldn't always build apps by thinking that social sharing is the most important thing. So that's something that I'm pretty passionate about right now and trying to get more people interested in and helping with.
How are you doing this private? Like, are you using any algorithms to like keep them private, like the data at least, like in your locally?
Yeah. So real simply, it's first and foremost, it's a web app. It's built with open web technology. It's not built with any transpilers or anything. So you can see all of the code, exactly the code that's going to run on your device. It's an installable web application, which means once it's installed, it runs locally on your device and it's not reliant on, nor does it ever send even a single byte of communication off of your device. So once you download the app, it's completely local and totally offlineable on your device. Secondly, it by default and without the option to avoid, everything that you store on your device is encrypted. You choose a local passphrase, which is different and I think a little bit better than a password. You choose a local passphrase. We derive a strong encryption key from that using the best hash derivation algorithm that exists right now, which is Argon 2. And then we encrypt using AES 256, which is the best practical encryption that we can get on a local device. So all of your data by default is encrypted on only your device. That does mean if you throw your device in the toilet, you might lose your data. So there are options for how you can decide that you want to share your data with another one of your devices, either as a backup or as a synchronization. We've got some interesting ideas about. I don't know if anybody here has ever heard of the concept of an animated QR code, but that's actually a thing where you can transfer data by animating frames that each frame has its own QR code in it. And that's one of my several ideas for how you can locally transfer from device to device without having to involve a server. So we're using a lot of tricks like that. And basically, there's a whole bunch of features that people want that require a server. And I'm basically just saying we're just not going to do that feature because we're not going to cross the threshold of ever involving a server. So we'll figure out how to do it local only, or we just won't do it. Is kind of the hard and fast rule here.
I wanted to talk to you about like types in JavaScript. Like, do you think TypeScript is needed or no?
Well, this is perfect timing because literally earlier today, I posted up a draft of a chapter in my most recent book that I'm working on. A lot of people know about the You Don't Know JS series. You may be aware that I've been for a while trying to rewrite the second edition of this book series. And these are not simply revisions of the previous books, they're complete rewrites from scratch. I am most of the way through the fourth book. Two of them were officially published a couple of years ago. One of them, the third book, is kind of draft complete. And then this fourth one I'm working on. And what I just posted today was the chapter on coercion. And a fair chunk of that chapter is dedicated to addressing the role that I see TypeScript playing among the JavaScript ecosystem, and in particular, the interaction that it encourages or discourages with JavaScript's type system. So I would encourage people go check out that chapter 4 that I literally posted on my GitHub today, and you can read in detail what I'm about to summarize. Number one, I'm glad that TypeScript exists. It has pushed the status quo forward, and it has addressed a real need, which is that prior to TypeScript, the vast majority of JavaScript programmers were not programming with hardly any what I call type awareness, meaning that they are fully aware of and understanding all of the types that are interplaying in their program. Most of the time, JavaScript developers were simply offloading that work to the JavaScript engine and then cursing whenever they ran into a bug with it. And consistent with my whole style of trying to convince people to learn things more deeply, I think if you're going to write JavaScript, one of the big things you need to do is learn how JavaScript's type system works, how its built-in values work, how coercion works. And unlike virtually everybody else of my peers, I actually think that JavaScript's type system is really compelling. And I think coercion has a lot of power that we're not using properly because most of us haven't spent the time to learn it. So I see my role as trying to convince people you should learn it and then providing them the tools to do so. And I see TypeScript as largely a crutch at this point for people that were struggling mightily with not understanding the type system. But rather than solving that problem by learning the type system, they reinvented a whole new type system and bolted it on top of JavaScript. And I think if you take a step back and if you ask, what would a really good coherent design for a statically and strongly typed language that was going to deliver or be delivered through, rather, the web platform, if you asked what would that language look like, I think you would be crazy to answer it would look like TypeScript. I mean, I literally think that TypeScript is the worst of all possible language designs for that task. It started as a compromise, which was, I want to keep doing JavaScript. But you have to understand that TypeScript was invented before the reality that we have today, like WebAssembly. WebAssembly is a far better way for statically typed languages to target the JavaScript engine and deliver through the web platform. And ironically, TypeScript is probably never going to deliver through WASM. But there's a whole bunch of other fantastically designed statically typed languages. Pick Java, pick C++, pick Scala, pick any of these languages. Rust, right? Exactly. Pick any of these languages. They're all coherently designed with static and strong typing from the beginning. I see TypeScript as the worst possible compromise because it neither serves that role well. It's not a well coherently designed static system because of all of the JavaScript reality that it compromises on. But it doesn't serve JavaScript well either. And that's probably my biggest complaint. It doesn't serve JavaScript well because it tells JavaScript developers you shouldn't learn the type system. You should just rely on TypeScript's type system. But at the end of the day, TypeScript types are erased. The TypeScript compiler removes all of its annotations and it ships regular JavaScript to the JavaScript engine. So at the end of the day, you're running JavaScript that you hope TypeScript was able to check all of your stuff, but you're running it completely unprotected. Your JavaScript program is running completely unprotected because the types were erased. This is just, if anybody before this stepped back and said, what should we build if we had a green field and we could build the right thing? This is the farthest from what anybody would rationally say we should build. It's a giant crutch of compromise. So I'm glad that TypeScript exists, and I know that there are a lot of people that like TypeScript, but I wish we saw TypeScript as a bridge to picking a different and better designed statically typed language. If that is your persuasion, if you like to write static and strong typing, and you still want to deliver through the web platform, you should be able to do so. I just think you would be far better served by picking a language that was designed to do that from the beginning. And bolting that on to a dynamically weakly typed language is incomprehensible to me. So what I'd love is for all the people that love TypeScript to go look at another static and strongly typed language and fall in love with that, because I think they'd be more well served, and I think overall the health of the web would grow, and TypeScript would then be a migration path and a bridge rather than a target in and of itself. So it does play a central and pivotal role, and I don't deny that in any way. I just do not drink the same Kool-Aid as to think that this singular monoculture is the right answer. What we need is to have a higher bar. We need a higher bar, and that's basically what I argue in this chapter, which is that all developers, regardless of what language you choose, need to be programming with full type awareness completely in their mind. And you also need to have full type awareness when you read code. And TypeScript is far short of that bar, unfortunately. It just isn't fully that. So even if you were doing TypeScript, you would still have more that you needed to learn and more that you needed to do. So if we set this higher bar, the higher bar is I think most appropriately addressed by actually learning JavaScript's type system and learning the most effective ways to be type aware with the JavaScript code that you write. And if you don't like that JavaScript type system, you should just pick a completely non-JavaScript language, of which there are dozens to choose from.
What do you think about JavaScript implementing the static typing instead of as using a different language, as you say, for TypeScript?
Yeah. I think it's a train wreck. It's a slow motion train wreck. First of all, they're not going to, the proposal the TC39 is currently considering, and I think inevitably will eventually land. That proposal is not to adopt TypeScript types. That proposal is to create a set of exceptions in the JavaScript syntax that allow some of the TypeScript types to look like their code comments. That's very different than saying JavaScript is going to start supporting TypeScript types. What they're basically saying is, here's a couple of different places and patterns where types are expressed in this typically statically typed kind of way syntactically. And if we can recognize those as not JavaScript, but as this other kind of thing, then we can simply treat that as code comments and ignore it. Okay? So that is what they are considering. And if you step back and ask, what's the motivation behind that? One of the big talking points is that people who write TypeScript do sometimes lament that the code that they write cannot natively be interpreted by a JavaScript engine because it has non-standard syntax in it. And so the theory is, if you could take the JavaScript engine and teach it to ignore TypeScript types as if they are code comments, then you, at least in theory, could run your TypeScript code directly in the browser without ever running it through a compiler step. And that should be more ergonomic developer experience, to be able to test your code out with a refresh of the page instead of rebuild of your project. There's a couple of problems with that. Number one, the subset of syntax that they're going to be able to recognize and treat as code comments is going to eliminate a non-trivial amount of valid TypeScript syntax. So you're effectively going to have to decide, as a TypeScript developer, do I use that stuff, which I like, for example, enums? That's the big one that everybody's kind of upset about. Enums is a TypeScript feature that is not currently slated to be supported by this types as comments or types as annotation comments proposal. So that means that if you use enums in your program, you're still not going to be able to run that code in a JavaScript engine. Even if all the other stuff that was types could run, that disqualifies your entire program if it shows up in your file.
It goes even beyond that, because a lot of people use TypeScript for like discriminated unions, interfaces, even generics. It's like you're effectively giving up everything that you like about TypeScript.
I don't know that it's everything, but you're giving up a non-trivial amount of what people like, right? So we have this question as to how is the TypeScript community going to react to that reality? Are they going to stop using that stuff? I think likely not. So they're not going to get any of the purported benefit of this. Um, and what we're going to face is that whatever the subset is, there's going to be an even stronger and more vocal contingent of folks who are putting pressure on TC39 to figure out a way for the JavaScript syntax to support as comments more and more of the TypeScript stuff. That will be a constant battle that will be fought, not for the next year or two, but for the next couple of decades. There will be this pressure to say, can't you come up with a way for this thing, this generics to be ignored and this enum to be ignored, and so on and so on. There will constantly be the pressure. Once you take the step of supporting any of it, there will be the pressure to support more of it, because there will be more and more TypeScript developers who want for their code to be untouched, be able to run natively in the JavaScript engine. I think that's going to provide an unhealthy set of pressures on the language. And we've seen pressures like that before. We actually have precedent for these constituencies that are pressuring the JavaScript language to add things for their particular constituency's concern. We arguably have a number of features in JavaScript right now which really have no business being in JavaScript, but they're in the language because people prior to WASM were so desperate to get their programs on the web platform that they pressured TC39 enough to add it. I'm thinking of things like proxies. I know that some framework authors like to write proxies, and I think they're very cool as a metaprogramming technique. But they largely exist because there are certain transpilers that were targeting JavaScript and using proxies to make it happen. And there are other features like that. Shared array buffers is another example. Atomics is another example. The pressure to add those to the language overcame all of the objections that I think were quite valid, which are, these don't even make sense for JavaScript. This is not how JavaScript doesn't need these features, but we pushed them into the language, and now we can't take them out. We pushed them into the language because we were serving those constituencies, and we had no better answer for them at the time, right? You know, the people that wrote the Unreal game engine and wanted to get Unreal to run on the web, and they wanted to use Emscripten and transpile to JavaScript to do it, they had a set of demands of what they needed the JavaScript language to do. And TC39 really was not going to be able to withstand that pressure forever. So those things landed in the language, and I lament the fact that they did. What WebAssembly largely provided a breath of relief. It was like a pressure release valve to say, now, if you want to target the web platform with language features that don't make sense for JavaScript, the answer is not shove them into JavaScript anyway. The answer is use a different language with those features and target WASM. That's a much more reasonable and sensible approach. What I fear happening is that same thing restarting in the TypeScript world, this demand to add more and more of that. And it is not simply that it makes the language more complex to learn. It does do that. It increases the surface area of complexity, makes it harder to teach as a language. But the real cost of all of this stuff is that every time you add a piece of syntax into JavaScript, you are constraining a future decision of syntax being added. You take away an operator and you reserve it for this purpose, and now that operator cannot be used. You take away a keyword for some purpose, and now it cannot be used in the future. So there is a real cost to the future development of JavaScript. The more times they say yes to things like that, the more times in the future they'll have to say no, or they'll have to compromise and design something in a substandard way, because JavaScript has all of these constituencies that it serves, and it's maybe the only language in the world and in the history of computer science that had such a varied set of constituencies to serve. So these are real problems that I don't envy the TC39 committee for. It's difficult, and I can't imagine how they juggle all of these things. I
Random
worry
question.
that TypeScript will continue to make that even harder. Yeah, go ahead.
Yeah, random question. Have you ever considered becoming a part of the committee so you could have more direct influence?
This is a very loaded question, and I will choose my words carefully. I think most of TC39, or at least a strong contingent of TC39, and myself, I think we mutually agree that it's better for me to be on the outside than to be on the inside. And I'll leave it at that.
Okay.
Anyway, so just to finish a long train of thought here on the question of this proposal. One of the problems that we have is, what if they are treated as comments, and we have this like forcing function of, well, I want this syntax to also be treated as a comment, and that will set the precedent that other people will come up with things and they will say, can you make exceptions to the syntax to make this also a comment? That's, once we do it once, we've opened the door, and that's going to happen a lot more. So that's one set of problems that I have with this proposal. There's another set of problems that I have which might even be worse. There are a number of vocal proponents for this idea of allowing TypeScript types, or these type annotations. There's a number of vocal proponents who are saying, well, would it be awesome if we had the JavaScript engine see that I had annotated a variable as an int type, for example, and put in an optimization for that? Wouldn't it be awesome if the JavaScript engine could take some hints from the TypeScript types and make its optimizations based on that? And I think if you didn't think about too deeply the implications of that, I think most people would say, well, hell yeah, that would be awesome. How much greater would this be if we could use all of that developer expressed intent to give more hints to the engine so that it could do better at optimizing and run code faster? That sounds like a win all the way around. There's a major problem with that. And that is that, number one, the current proposal treats it as a comment. You can't simultaneously treat something as a comment and also treat it as a piece of concrete, meaningful syntax. You kind of have to pick, because the way abstract syntax trees work, which is the output of a parser, it throws away that non-required stuff like comments and white space and stuff like that. So by the time the JavaScript engine gets these, it's not supposed to see any of those types, because that stuff is supposed to have been thrown away, just like all the other white space and code comments were thrown away. So if you now say, well, actually, we don't want to treat them as comments. We want to treat them as this special in-between kind of a node that we're going to stick in the tree. We're going to kind of ignore it, but then sometimes not ignore it, and we're going to use it. That reality, first of all, is going to exponentially increase the complexity of the tooling ecosystem for JavaScript, and the parser ecosystem in particular. It's going to make it exponentially more complicated to create good interop between tools and think about your tool chain. But the other thing that it's going to do is it's going to effectively make the usage of TypeScript become a required thing in JavaScript. It will not be seen as optional from that point forward. Because if you take two programs that are otherwise written identically, and the only difference between them is that one of them has a type annotation in it, otherwise their logic is exactly identical, and you benchmark those, and the one with the type annotation runs measurably faster, more optimized than the one without the annotation, once that message starts getting out there, every manager, every client, every boss, every project manager will say, we have to have that stuff in our code because we have to have the most optimizable version of any program we write. And so we fast forward a couple of years, and we will have moved from TypeScript is a choice in the industry to TypeScript has become the dominant monoculture. That's the only way that types are done, because it's the only one that was blessed by the JavaScript engines for optimization purposes. That is a terrible future that I'm terrified of. So I just don't see any possible way that this proposal is going to make things better. No matter how you slice and dice it, I think I would like to say, well, maybe this one case it'll be like, I can't come up with a single argument for why I think it's going to be better, but I'm pretty convinced that it's inevitable. The pressure is so great. There are so many people that are enamored with TypeScript that I don't think TC39 is going to be able to withstand that pressure for too long.
So what are some of the more interesting language features that are coming down the pipeline in future versions of JavaScript?
So there are several things that I am interested in and would like to see move along quicker. Pattern matching, that's a favorite of the functional programmer world. There's been a proposal, a good solid proposal for pattern matching for years, and it's stagnated. And I would be excited to see that one pick back up steam. Probably the biggest feature I think that's about to land. It just advanced to stage 3, which means it's likely on its way to the language, coming to a language near you soon. Is records and tuples. These are new primitive data types that are corresponding to objects and arrays respectively. So a record and an object are a dual of each other, and a tuple and an array are, I'm sorry, a record and an object, a tuple and an array. I don't know if I said that wrong. Those are duals of each other. A record is an immutable object by default, and it's a primitive, so it is compared by value equality rather than by reference equality like objects. So you can take two records that are arbitrarily deep of complex with data in them and do a simple equals comparison between the two, and they'll be equal if their contents are equal, irrespective of order. That's something that we cannot do right now. Like deep equality matching is a giant clusterfuck in user land, and we're going to get that natively in the language when records and tuples land. So having by default immutable data structures that have value equality comparison, value comparison equality, that's going to be a huge thing. So I'm super excited for that feature. I hate the syntax they chose for it. I argued vehemently for them to pick a different syntax, but whatever. It doesn't even matter if it's terrible syntax. That is such an important feature that I want to see that. And I guess the third one that's also been stagnant for a long time, but I think would fix a giant set of problems that JavaScript has had for a long time, would be do expressions. One of the big problems that JavaScript has is that it was originally designed to distinguish grammatically between statements and expressions. And if anybody out there is listening and has some thoughts or ideas about designing a language someday, please, for the love of God, do not distinguish between expressions and statements. All statements should be expressions. There should not be special grammar rules for statements. This was a terrible decision, but it was a decision that was made nonetheless, which is why, for example, you can't use a try-catch statement right in the middle of an expression the way you would like, because that's a statement and it's not an expression. So we can't fix that, unfortunately. I wish we could. But the next best thing is do expressions, which are effectively a little bit like lightweight ifs. They turn any statement into an expression, and they evaluate the statement and return the result. So it's a little bit like an iffy, a little bit like an eval, but not. But it's going to solve this distinction problem that we have between statements and expressions. So we're going to be able to use statements wherever we use expressions, and that's going to be a big improvement to the language, I think.
Do you see? I think TC39 was the people you keep referencing. You mentioned bringing over records. Do you think that JavaScript will also bring over partials as well?
What do you mean by partials?
So TypeScript has this thing called partials, and I'm not a super expert, but I believe it's like you pass in. Let's say you want to pass in a record, but the record expects both an age and a breed, right? Or an age and a name or something. But that a partial is basically a type of a record, but it doesn't have to have all the key value pairs that it would that would have to be associated with that object. So you could have an object that looks similar. Let's say you have a record for name and age, and then you have a record for name and gender, right? They both have names, but then you could pass in a partial, and you say, okay, hey, this partial type could say, as long as the key exists of what I'm looking for, then it can be accepted.
That's an interesting type related feature. I don't have any experience with that particular style of programming. I'm not aware of any proposal to bring that to JavaScript. But my standard response would be, if TypeScript has it, there's somebody who's trying to get it added to JavaScript. So there probably is a proposal to add it. I don't know what the appetite is on TC39 for something like that.
Gotcha. Okay.
I say that JavaScript has map, but everybody's using objects everywhere. Like every code that I've seen, like 90% of the time, everybody's using an object. Why do you think there is a reason for us to have a map and no one is using it?
Well, I don't think it's fair to say that no one's using map. If you look at any code base, you're likely to see some instances of for each, filter, map, reduce, etc. Those are all part of the standard lib for arrays. So they're all on the array prototype. Functional programmers know that the generalization of those operations is that they can be used on any data structure, not just on lists. And so any functional programming library is likely to use a generalized map that can work on objects, and they probably are using that. I mean, I've written map to work against binary trees before. You can generalize those operations to any data structure. But JavaScript didn't add map to the object standard lib the way that it did to the array standard lib. And I think you could argue that part of the reason why they didn't do that is because they don't really, I don't think, consider functional programming to be as much a first-class citizen as they clearly think that class orientation is a first-class citizen. So I think you can argue that there should be object map that is generalized to work over the maps. But I think mostly TC39 is content with the fact that the people who care about stuff like that are just using userland libraries to do it. I've done that, like I said, dozens of times. All the major functional programming libraries support those kinds of things. And in fact, there's multiple ways to slice and dice that and solve that problem. But Ramda and Lodash-FP and all that, they all have things like that. So I don't think that the lack of that being in JavaScript is indicative of it not being important. It is important. I think the lack of it being in JavaScript is reflective of the idea that a non-functional programmer doesn't know anything about functional programming can look at a code example that is using something like map or filter and intuit why that's useful. But when you start talking about the more complex generalizations, you start talking about monads and things like that, that's never going to be in the language, because to understand how those work, you have to have so much of a deeper awareness of all the ins and outs of that line of thinking, that paradigm of thinking. So array map and array filter and stuff, they're in the language because they're such low-hanging fruit that it makes sense for them to be in the language. And the other stuff that's not quite so low-hanging, it only lives in userland. They didn't need to add it to the language.
So the map I was talking about is the one where it has a key value pair in there.
Sorry, I thought you were talking about that.
Yes, I know, but I was like, okay,
My apologies.
That's fine. But
We went off on a total tangent that I was totally wrong.
So
Okay.
that and object, like both exist,
Gotcha.
both almost do the same thing, even though like objects I think are like null, like all of the values inside object are null. But
No, not really.
Okay, why do you Which one do you prefer, object or a map? Like
Well,
a map
so
object, I guess.
that's like saying, which one do you prefer, an apple or a sports car? They're totally different things. They're completely orthogonal, right? I can prefer apples, and I can also prefer sports cars. They do different things. So the major difference between an object and a map is what's allowed to be the key. In an object, the only thing that can be the key is a string or a symbol, which is also another primitive. It's strings and symbols, and that's it. When you want to use something more complex, like another object, like a DOM element or a function or whatever, you cannot use that as a key in an object. So the map data structure exists because that's what it does. You use complex objects like objects, arrays, functions, etc., as the keys with which you associate data in a map data structure. So my answer is, anytime that I need to use a non-primitive string or symbol as a key, I use the map data structure. Anytime all I need is string keys, I use the object, because that's what they're both best at. So it's an and, not an or.
So what are some situations you would actually use like the map, like the advanced string keys?
So I use those quite often, actually, depending on what you're working on. One of the main reasons why you might prefer a map, again, if I have a value that represents, let's say, like I have a value that is a DOM element, right? And I want to associate some additional information with that DOM element. I want to be able to retrieve that information. If I have a reference to that DOM element later in my program, I want to retrieve this metadata that I'm saving with it, right? Could be some additional model data that my application associates with it or whatever. I cannot use a DOM element as the key in an object, but I can use a DOM element as the key in a map. So I would insert an entry into the map for that DOM element, and the value would be a collection of all the data that I wanted to store for it. And then later, somewhere in the app, if you provide me a reference to that same DOM element again, I can ask map, hey map, do you have this as a key? And if so, give me that data, right? So the only other way of doing that, if I wasn't storing it in a map data structure, would be to mutate the DOM element itself, which you hopefully can see would be a bad idea. If we don't own something, we shouldn't be mutating it. But that would be the only other way for me to store some data with it, would be to like just add properties to the DOM element and hope that they stay around. That's a bad move. So the best way for me to associate some arbitrary data with an arbitrary non-primitive value like an object or a function is to make a relationship in a map data structure.
Got it. So I know you've been teaching for a very long time. What are some of the the gaps that you see with a lot of JavaScript developers that you've been teaching? Like where should developers start focusing on?
Well, I've already said that I think one of the biggest and most skipped over things that developers have is that they have a blind spot, that they take for granted the type system and specifically how coercion works. Anecdotally, out of the 6 books of my first edition You Don't Know JS series, the types and grammar book it sold half as many copies as any of the other books. So that's only anecdotal evidence, but it suggests that people look at a topic like that and say, I've already got that. I don't need that. And the truth is that by and large, they don't. And they are skipping over that to their own detriment. So I would say that's maybe number one. And the second thing that I think developers in JavaScript understand very poorly or hardly at all is notions of asynchrony, concurrency, the event loop, and how to actually manage stuff. We almost did them a disservice by giving them primitives like promises and async await, because that was almost like, hey, you know how you used to struggle with this? We're going to solve it for you without you needing to learn what's actually happening. So we see people just using those primitives and using them poorly, but using them because they kind of paper over some of the concurrency problems that an engineer would typically need to think more carefully about. I'm actually reading a book right now. I just picked this book up a couple of days ago. The title of the book is Multi-Threaded JavaScript. And it's an interesting title because a lot of people think that doesn't make any sense. JavaScript is single-threaded. We all know JavaScript's single-threaded. Well, it's more complicated than that. And this book dives into that. But part of what it dives into is that if you are going to move beyond something like the microtask queue that promises provide, like move outside of the world of asynchrony into the world of true concurrency, JavaScript has a whole lot of ways that it interacts with its environment in a truly concurrent way. If you're in Node, that looks a little bit different than it does in the browser, but there are several different primitives that we really need to learn and get much more comfortable with. In the browser, for example, being able to really fully leverage web workers is useful. But when we move into Node land, we have both multi-process and multi-threaded capabilities that Node provides, and very few Node developers ever take advantage of either one of those. So there's actually a whole bunch of stuff that I think most people just kind of gloss over, and they say, "Oh, it's fine. All I need is a callback or a promise or whatever, and that's all I need to know." So I think JavaScript developers should spend a lot more time understanding asynchrony and concurrency.
Okay. I've seen a lot of bootcamp people and also like normal people like learning frameworks before they learn JavaScript. They learn JavaScript through like using React or Angular or some other framework. What would you recommend for them, like when they're trying to come back and actually learn the intricacies of what JavaScript actually has to provide?
So here's another one of my hot takes. The fact that most of the people who enter the JavaScript ecosystem and start learning JavaScript, the fact that most of them learn frameworks first, or at least heavily emphasize the learning of the framework before and during and after learning bits and pieces of the core language. The reason that that is the case is not for any fault of their own. What we should do is take every single hiring manager in the world that hires JavaScript developers and fire all of them, because at large, they are just totally bastardizing our industry by only hiring based upon things like, do you know these keywords about, the React framework or Angular or Vue or whatever? Like, it's their fault. We have created an industry that so clearly rewards understanding how to get something done in a framework and having no idea how it actually works under the covers, that it would be crazy, it would be silly for a new learner coming into this language to buck all of that and go learn the language deeply and not get a job, right? There are people who could go and spend 6 or 12 months deep diving and learning all about the JavaScript language, and they could show up to a JavaScript interview, and number one, the hiring people would be asking questions that were wrong because those people didn't take the time to learn JavaScript. That happens all the time. And number two, they wouldn't get the job because that hiring manager would say, "Okay, well, show me what you've done with React." And they're like, "No, but look, I know all about JavaScript. I can pick up React in a few weeks, but look at all my skills with JavaScript." And they're going to say, "Well, that's not what we're hiring for." So it's actually the hiring problem that's causing this. It's not that people don't want to learn stuff. It makes complete sense why people focus on that thing, because virtually our entire industry has rewarded exactly that. So we've got to fix that problem before we're going to fix the learner problem. And I don't begrudge. I work with code schools. I help them. Literally been working with a code school, the School of Code based in the UK. I've been working with them recently. I don't begrudge them at all teaching these frameworks. It's completely practical for them to do so because they're putting candidates out into a workforce that is so completely skewed on this topic as to not really care whether you know why it works. Really, the only thing they care about is, can you get it done? How quickly can you ship a new component? That's the only thing that seems to really matter when it comes down to it. And I myself have spent the last 3 months on the job search and been largely frustrated by the fact that no matter how much JavaScript I know, my desire to focus on bigger things means that nobody wants to hire that, right? Nobody's hiring for that. They're only hiring for how quickly can you come in and sling some React code, or how quickly can you get an Angular program, app up and running. That sucks. But it's not the learner's fault. It's the hiring manager's fault.
So do you feel like the interview process is pretty much broken in a lot of regards?
100% top to bottom. There's nothing redeeming. It should be completely thrown out and start from scratch. I don't know if that's clear enough, but yes.
So if you were to conduct interviews, like how would you go about it? Like what would you change?
Yeah, I've written about this in the past. If people Google some of my thoughts on tech interviews, you might find some posts I've written about this in the past, but I'll kind of summarize. First of all, I actually think that the question of can you code or not, which is basically like a screening kind of a question, that sort of a question is not something that we should be using the interview to answer at all. We shouldn't. The concept of a screening interview is total bullshit and should be completely thrown out. There are far more effective ways to screen for what I think is arguably a smaller segment of the interviewing community, which is that they're just straight up lying. They're straight up pretending that they know something that they don't, and they've deep faked their image, and they've outsourced it to somebody in India or whatever. Like that does exist, but we are dramatically overemphasizing the concern that might happen in an interview, and creating a whole bunch of other structural problems for the industry because we're not giving that the proper amount of attention, which means we need to give it a lot less attention. This worry, this concern about screening. Ideally, if I were going to screen a candidate, what I would like for that candidate to do is provide me link to some, like a GitHub repo that they've done, that they've worked on. And it doesn't even matter whether they wrote all the code or not. Like it could be a team project or something like that. But ideally, what I'm looking for is actually not so much the lines of code that they've written. I'm looking for all the other stuff. Like, for example, how did they triage when somebody reported a bug? Were they a kind and empathetic human being? Did they ask good questions? Did they provide good details? How did they do with documentation? How did they do with tests? All that stuff. That's what I'm looking for. I could get a pretty good sense from a screening perspective by looking at the GitHub history of some project. If it's been around for more than a few months, and there's more than a couple dozen commits and a couple dozen issues, I think we can get a lot of that screening done. Now, it's quite true that a huge chunk of the hiring community, a huge chunk of the candidate community doesn't have that. And I fully recognize that if you don't have that, we need to provide something different. So here's what I would do instead. If you did not have that, and you applied for the job and I was the hiring manager, what I would do is say, okay, here's how your hiring process is going to look. We are going to work together for short amounts of time over the next 7 days. Expect to spend up to about 30 minutes a day over the next 7 days. You can do that 30 minutes anytime during the day, your lunch, late at night, it doesn't matter. But what's going to happen is I'm going to assign you a private repository that you and I are going to work on. And I've already preloaded it with some code. So what I first want you to do the first day is I want you to go in there and file a couple of issues for open tasks that you see that need to be addressed. And I'm looking to see, can you drop into an existing code base and analyze the status of it and figure out what needs to be done? And how good are you at describing those things in plain and simple language when you file an issue? So that's the very first night. The second night, I'm going to file a defect against part of the code. And I want you to spend 30 minutes fixing that and triaging the bug report that I filed properly, ask the right clarifying questions, fix the bug, and commit that fix. The third night, I'm going to, do something. Basically, I'm just going to run through the entire life cycle that a software engineer interacts with a piece of code. I'm going to create that experience for you and ask you to run through those steps. And I'm going to be observing how you do with that stuff. One of those is going to be, I'm going to ask you to write some documentation. Then another night, I'm going to ask you to submit some tests for a piece of the code that's not currently being tested. I'm going to do all of those sorts of things to give you the opportunity to show me how you interact in that kind of environment. You didn't have that from before, and that's okay, but you're going to have to spend a little bit of time showing me that you can do that. So I'm setting the expectation it's going to take you up to 30 minutes a day for the next 7 days to do that. By the end of that process, whether you submitted me a GitHub repo or whether you ran through that little process with me and I was able to look quickly at what you were doing, I'm going to have every question answered that I could possibly imagine from a screening perspective. I'm going to know what your technical and what your technical social skills are. In other words, how you triage, how you communicate, your empathy. I'm going to know all that stuff. At that point, the mode that we're going into is if I'm happy to continue, then I'm going to provide you the feedback at that moment as to what I liked and what I would like to see better, right? I'm going to give you feedback right in the middle of the interview process so that you don't have to wait till the end. You can get some feedback, and I'm going to give you some notes, at least a paragraph of the good stuff and at least another paragraph of the stuff that I would like to see more strongly represented. Maybe give you some prompts to say, this is stuff that you need to show me, later in the interview. This is stuff that I would still be looking for. But if you agree that we continue and I agree that we continue, we move on to the next stage, right? So that's how I would approach this, whether I've reviewed an existing project or whether I've run you through a little microcosm of that project. At this point, now I'm ready to commit several hours up to a half or 3/4 of a day of my team's time to interview you. But I don't need anybody on my team to screen you for all that other stuff because I've already seen all of that and we've already got that out of the way. So I'm looking for a whole bunch of other things when I bring you in for the in-person interview. The first 10 minutes that you're in the interview, I'm going to convene a stand-up of the team that you're a candidate to be joining. And I'm going to ask you to go and observe that stand-up and then come back and report to me. You don't have to say anything in the stand-up. I just want you to be an observer. Listen. And then I want you to come back and spend a few minutes and report to me what it is that you heard was going on in the stand-up. Tell me what you see, what did you hear? What issues are we struggling with? What things do we need to tackle? Where are the missing pieces of the puzzle? What did you observe? Just come back and dump that, whatever you observed for me, the good and the bad. Then I'm going to take, say, 30 minutes, and I'm going to pair you, do a pairing exercise. I'm going to pair you with one of my more seasoned engineers. And I'm not expecting you to do any code, but I want you to watch them work on something. They're going to be trying to fix a bug. They're going to be working on adding a feature, whatever. And again, I just want you to observe. You can ask as many questions as you want about what they're doing, but I'm just looking to see you observing them doing the process of development and then come back and download for me. Tell me, dump for me, what'd you get out of that? What'd you see? What'd you think about the code that you saw? What'd you think about how that engineer was approaching it? What would you have done differently if you were driving the keyboard? Just tell me that stuff. I want to see your observational skills with a person. Can you communicate? Did you ask good questions, etc.? Then I'm going to take the team and have them do like an actual more substantial meeting, right? Like not just the little quick stand-up, a more substantial meeting. Maybe it's a small subset of the team or whatever, but there's going to be a substantial meeting. And again, I'm going to ask you to go to the meeting. You can or cannot participate. It's up to you. But again, I'm asking for you to come back and tell me, what'd you think of that meeting? Did the meeting run well? Did you think it was efficient? Was it too long? Was it too short? Did you think it was productive? Just tell me what you thought about one of our team meetings. Probably the last thing that I would do, and I would have prepared the candidate in advance of this, is I would say, I want you to take up to 30 minutes and teach me something that you know. Even if I know it, I just want you to teach me something that you know. So you need to be prepared when you come to the interview to have something, whether that's like, I'm going to teach you a coding thing, or I'm going to teach you something about beekeeping. Like, it doesn't matter. I just want you to teach me something for 30 minutes. And I'm going to observe, how do you communicate? How do you teach me? By the end of that process, I've spent maybe 2 or 3 hours at most reviewing and screening you and looking at how you work with a GitHub repo and all of that stuff. And then I've spent anywhere from 3 to 6 hours on site, time that you interacted with different people on my team. And I'm going to have way more than enough signal to know if you're a person that will match my team and fit my team and do what I need in a hire. So if I had a green field and could design an interview process, it would look a lot more like that. And you'll notice that very little of what I just described resembles how we currently approach job interviews.
I think this gives a candidate a view of your team too, how they work
Yeah.
inside, and if he doesn't like it, he can also leave. Like that's
Exactly. That's one of the main goals, is make sure that it is super obvious to both sides what we're getting into. We want to make sure that everybody thinks that this is a match.
So yeah, we got a question in from a watcher and also a participant of the show. He wanted to
Okay.
know, like, there's a deluge of courses and books and things out there. So what would you recommend, like a beginner? Where should a beginner start?
I think the biggest thing that you need to do as a beginner is recognize that you will not be able to learn effectively on your own. I think there's far too much propping up of the autodidact culture, the self-learner, the guy or lady who sits all night long and watches YouTube videos or whatever. That's what I call Neo from the Matrix model. If I plug in 10 minutes later, I know jujitsu or whatever. Like, that's not how humans work. We learn and grow in community, in connection, and through relationship. So the first most important thing that I would tell anybody jumping into this journey is find a community. And if you can't find one, make one. So there's a lot of different ways that communities can be built. You can, for example, do a book club. Find a couple of people that you can talk to over social media and then say, hey, here's a book that I think we should all read. And let's just do a book club and we'll meet once a week and talk about it, right? Or whatever. Now you've built a community of people that care about each other and trust each other. And that's a community that you can lean on when you're trying to learn things, when you're trying to bounce ideas off of them, when you're trying to get collaborators to help you. Of course, that's not the only way to build community. Going to local meetups in your city, virtually every city's got meetups, and going to those is a good way to find a community. Free Code Camp is a huge online community that is a great place to go looking. So find a community to learn from is kind of like, I mean, it sounds almost too simple, but I think it's profoundly missing in most people's journeys. And the people that I've seen that have done that have far exceeded expectation. They've grown so much quicker and produced so much more out of their careers because they knew that the best way to do that was in concert with other people. So kind of the big tip that I think people should do when they want to learn. The content is not nearly as important as the relationships.
Is there a way, like, would potential watchers, would they be able to reach out to you for like coaching or mentorship?
I wish that I had the time and the mechanisms to scale that. Sean here will know that I've got lots of thoughts about the kinds of tooling that I wish existed to enable a more scalable version of that. Unfortunately, what I do right now is a very ad hoc, like I answer questions when people email me something or when they ping me on LinkedIn or some other social media. I answer questions when and where I can. I probably delete 10 questions for every one that I have time to write a response to. And it's because I get, 50 of them a week. So I don't have as much time to do that as I wish I did. But unfortunately, I do not have a formal mechanism for offering the mentoring like I wish I had the time to do so.
Yeah, I know we're kind of running over time. Did any of you, y'all have any other questions for Kyle?
I don't.
All right. Did you have any closing remarks?
I guess the thing I would like to leave listeners with is, and I've got young kids. I've got a 9-year-old and an 11-year-old, and I'm Neither one of them, by the way, has any interest in software development, to my deep sadness and shame. I wished my kids would grow up and become the next JavaScript people or whatever, but they're into their own stuff, right? And they're both into theater and music and instruments and stuff like that, and I'm thrilled, right? But the most important thing that I'm trying to put into them, and I guess maybe the most important thing that I would like to put to anybody that's listening to me, is the importance of having a growth mindset, meaning that you deeply believe in your soul that whatever your current situation is, there is something that you can and should do to better that situation, that you can always learn more. If you struggle with something in JavaScript, you can always learn more of it. You are not constrained to be stuck in the status quo. If you're in the worst job that you've ever had in your whole career, it doesn't have to be a permanent condition. There is some way, and I know people listening may be in really difficult and challenging situations, and so it may be hard to hear, but I think that's kind of like, this is people advice. This isn't engineering advice. Human to human, what I hope that you hear is that there is a way for you to have hope that you can, that there can be a better step coming down the road for you, that you can improve your situation. There are people every single day who completely career change and from scratch start over and learn an entirely new career, whether that's engineering or something else. They completely start over and they reinvent themselves and largely never look back and never doubt or question the choices that they make. So in little and big ways, there is always that hope. And I guess a corollary to this would be to say that I have a recent effort that I've been trying to address, which is this notion of imposter syndrome, which I think a lot of people feel deeply and seem to struggle with. I think part of the problem with imposter syndrome is that we assume that this notion of being an imposter is automatically a negative thing. That if we somehow are an amateur or not yet an expert on something, then that means that we have not yet achieved the level of expectation that everybody else has around us. As if all the people around us are experts and we're the one sole amateur who's an idiot and doesn't know what they're doing with it. And so as a corollary to have this growth mindset and you can always be better, understand that no matter where you're at, that's good enough, right? Like it's good enough, whatever your current skill set is, it's good enough for you to do. I try to turn this notion of imposter from being a negative thing that you should shy away from and be scared of and ashamed of into a positive thing. Imposters are the only people who ever get anything done. If you waited around until you were an expert, you'd never do anything. By jumping in early and often and publicly and trying something and being open about the fact that you're trying to get better at this, and this is what I understand now, and next week I'm going to understand it even better, like that's what I call being a professional imposter, and that's what I strive to be. So I would encourage people, don't feel like because you haven't become some master or expert at something that puts you in this second tier. You're in exactly the same place as everybody else. We're all on a spectrum and all of us are on different journeys, but there's no experts around us. Everybody's an imposter that's just at varying stages of figuring it out. So hopefully those are, whether you're an engineer or you do something else entirely and you just happen to listen in on this podcast and you don't do programming at all, human to human, I hope that you hear that and feel inspired by that. So that's what I've got.
Yeah, that was some great advice, man. We definitely appreciate you coming on, man. You can come on anytime.
Thank you very much. It was a pleasure to be here. I enjoyed it. Thanks for all the great deep questions, and I appreciate you listening to me ramble on with my opinions.
It was great to catch up with you again also.
Indeed. Yeah, Sean and I go way back, so it's good to see you, Sean. It was a pleasant surprise to hang out on this call together.
All right. Thanks, everybody. We'll catch y'all next time. Peace.
Take care.